Okay. Our sponsor today is This.Labs, your partners in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. You can find out more at this.labs.com or send us an email at hi@this.co. We have two speakers for you here tonight that we're really excited to have with us. Thank you for joining us, Lucas and Chris. Lucas is an enterprise architect at JB Hunt, and he'll be talking about bringing to light the shadow DOM. Chris is a senior software engineer at This.Labs, and he will be discussing how to create lightweight GraphQL APIs with serverless. Welcome, you guys. Thank you for being here.
Yeah, thank you for having us.
And then we also have Blake with us tonight, who will be hosting our JavaScript Jeopardy, which is a nice little treat that we'll have for you in between the talks. He is joining us from Fayetteville JS. Blake,
hey, everybody.
Thank you for being here. So we have a few announcements for you tonight before we get started. We have several events that This.Labs puts on that we would love for you to join us for. Tomorrow, we have a partnered online GraphQL Madrid at 10 a.m., a monthly React Online at 2:30 p.m., and another online meetup that would have taken place in Kansas City, but we're all quarantined right now. So since it's all online, feel free to join us for the Modern Web KC event. Next week, we have our first GraphQL fireside chat about platform and data-centric use cases with GraphQL on Tuesday, plus State of View with Evan Yu on Thursday. You can find all of the links to these on our website, this.co. If you have any questions finding anything, please feel free to shoot us a tweet on Twitter or shoot us an email at hi@this.co, and we'll be happy to make sure we get those links to you. We would love to see you there. And if any of you follow us on social, you may already be aware of our new program that we just launched last week that we're very excited about. It's called JavaScript Marathon. Each week, we are bringing to you a day of live training covering various topics on React, Angular, Vue, web performance, and RxJS. You can find a full list of topics and a schedule of when they're airing at javascriptmarathon.com. So tonight our schedule, and this is a schedule that is typically more conducive for an in-person meetup, which was originally planned. So we might go through it just a little bit faster than normal. So obviously right now we're going through our welcome and introductions. Then we will move on to Lucas's talk on bringing to light the shadow DOM. Then we will take a brief break and have some fun with JavaScript Jeopardy. This is where we will ask you some fun questions. 95% of them are tech related. There's a few that are just fun little quips in there. But we would love for you guys to participate by commenting in the comments. We do have to warn you, there's a little bit of a lag with what we are saying and speaking versus when we might see your answers. But the first person to give us the right answer, we can't give you a prize right now online, but you get bragging rights. So we might have a little funny little awkward silences while we're trying to figure out if we're waiting for you to answer or if it's just a delay. So bear with us a little bit on that one. This is our first JavaScript Jeopardy in this format. So I think we'll have a lot of fun with it. But after that's done, we'll be moving on to Chris's talk, creating lightweight GraphQL APIs with serverless. And then we'll have a few closing remarks and say our goodbyes. So if we are ready to get started, Lucas, I am going to pass the torch over to you. And there you go.
Okay. All right. Well, I got to say, this is probably the most interesting talk I've given, well, given the circumstances of giving a talk sitting down in front of my computer. But I really wanted to talk about the Shadow DOM. So let me first introduce myself. My name is Lucas Dorrough. I'm an enterprise architect at JB Hunt, specifically for front-end development. And I've been in the Northwest Arkansas area for about 8 years now. Grew up in Arkansas. So bringing to life the Shadow DOM. The Shadow DOM, if you're not familiar, is part of the web component specification. And it's not something that really gets kind of focused on. It's definitely part of it, and it does get brought up, but it's not something like that you'll see directly. So let's go ahead and get into the problem and why the Shadow DOM exists. So I'm going to kind of do a hypothetical in order to set this up, a hypothetical that you've probably experienced before. You've been given a task to build an application. And for this example, I'm going to be using a very, very simple one. I just have a header tag and a button on the page, and then I just have some very basic styling to add some color to that header. And the bottom left, you can see the DOM tree of this page. It's just the body, the H1, and the button. So you've built this wonderful application, and you're about to go deploy it. But then you're told that in order to actually deploy this application to production, you need to pull in some header or have a header injected into your application in order to be compliant with your company's styles or the platform or whatever it is that they have. So that header, again, very simple for this explanation, I have here. It's just I have a nav tag with an H1 and a button. I'm making these tags very simple and kind of avoiding divs for the sake of this explanation. Again, the DOM tree, very simple, just the nav with the H1 and the button. We have a little bit more styling now. We just have some stuff for spacing and padding, as well as adding a little bit of color to that button. So that's all good. You know, both are very simple, and we're going to put them together and deploy it. And this doesn't look like what it's supposed to look like. The button in the application is now dark blue, and the title and the header is now light blue. So what happened here is what most front-end developers are probably aware of, is that CSS is global. So it doesn't matter where it is in the DOM tree. If you put that a button should be blue, it's going to be blue. Normally, we would fix this with CSS specificity. Otherwise, you know, just saying like, oh, well, this button that's under the nav should be this color, and all the other buttons should be this other color. And or you could use a class name to do this. There's a number of ways that you can increase CSS specificity in order to better target individual elements. The problem with this is that as your project gets larger and larger, it gets harder to keep track of, okay, well, if I use this ID before, or have I used this class before, you get instances where you've made things so specific that now it's harder to share those pieces of styling. Or maybe your teams are distributed, and so someone on team A has the same great idea for a class name as someone on team B. And so now, all of a sudden, one button or one piece of styling on one side of the application is causing some weird visual behavior on the complete opposite side of the application. And so this global CSS is seen, when you call it just a straight up problem, seen as a problem. So encapsulation saves the day. And that's kind of what Shadow DOM brings to the table, is being able to encapsulate both the HTML and the styles of that HTML. So for this kind of demonstration, even though Shadow DOM is mostly brought up in reference to web components, I'm not actually going to be building or showing a web component being built. I'm specifically focusing on the actual API of the Shadow DOM. How would you implement a shadow tree? And that's very simple, actually. It's a lot simpler than I thought it was when I read about this a while back. So all you do is you get whatever node that you want to have as your shadow root, and you just use attach shadow in your JavaScript in order to create a shadow tree under that shadow root. So you see in the top left of my HTML, I have removed all of the code from the navigation node, and instead I've just added an ID there of header. And then in my JavaScript underneath that, I am getting that navigation by that ID, and then I'm using attach shadow on that. And then I'm just appending some inner HTML. It's not the most elegant in my example, but it's just for the sake of simplicity. In that, you'll see that I not only have my HTML, but I also have included the style for that normally would have been included in like a CSS file or something. So now with the shadow tree separated out, and we have, if you see on the right, we have that box kind of around the H1 and the button, and that's called the shadow boundary. And basically, if you look at the, now that we've added that and we've deployed that to production, if you were to go look in your debugger, under that nav, you would now see this shadow root. And under that, you would see your HTML and your styles. And of course, our application is fixed. No more styles bleeding in or out of the shadow tree. We have that boundary there. And that's really, like, that is pretty much that's Shadow DOM in a nutshell. But there's some drawbacks to that. What about customization? So you've deployed this application, you've successfully prevented any type of styling coming in and out of the header. But let's say that this was a web component and I wasn't just having everything in one application, it was a web component. Well, now you have no access to modify that header if you need to. Like, let's say you have a different title, or you have, for some reason, different applications within a platform have different color schemes that you want to modify. You can't do that because everything is encapsulated. That brings us to a few different mechanisms. The first one I'd like to talk about is slots. Slots used to be in the version 0 of the Shadow DOM API. Slots was called content, but it's been renamed, and that actually is browser supported now, except for IE and the old Edge. It's supported in the Chromium Edge. So slots is a mechanism to get what's considered light DOM. Everything that's not Shadow DOM is light DOM. To get light DOM to be rendered through the Shadow DOM. So in this instance, I've removed the title in the Shadow DOM HTML, and I've just put a slot there. In that slot, you'll see I have no name. You can have defaults. So the default here, if no content is provided, then it's just going to say no name. You can even use, like, I could have more HTML within that if I wanted to. It's just swapping out that content. And you see in the users or the consumers, like HTML, whatever's consuming this Shadow DOM tree or the web component, I now have that title, my data application. And what that'll do is it's just going to, it's not going to move the DOM, it's just going to render it in that location. An artifact of, or a kind of a gotcha with that, because it's not actually moving. It's not it's not telling it to move that DOM into that slot. It's just a placeholder. So if you were to do this, where I've actually replaced the slot completely, or the header tag completely with the slot, and then I turn around and I put a H1 there, and then I also added this control slot with a button. Well, now we see on the right, well, this is kind of odd. The styling is now bleeding into the header again. Well, that's because that content that we're giving to the slot isn't actually in the shadow DOM. It's still outside of that, so that it's actually taking on the styles from the application. I forgot to mention, slots can also have names, as I have here. So if you have multiple slots within a given component, you can like specify which one you're actually adding to. This is kind of the visual of how the slots work. So you'll see on the left, the DOM isn't there. It just has that little arrow, and it's telling it that it needs to show that button there. And then on the right, kind of a visual diagram of the fact that the button's not actually being moved there. It's just revealed through the shadow tree. If you do need to style it, you can use this slotted pseudo element, which also used to be content pseudo element. It's been renamed as well. So at least they renamed both. They didn't just rename one. And that's also supported in modern browsers now. And basically that will just style elements that are being slotted in. It is worth noting that that will not stop those elements from taking on styles from the light DOM. So even though we're now styling it in the dark, in the shadow DOM, it's still going to have those styles. So just some little gotchas to kind of keep an eye out when using slots. Advanced styling. So slotting, the previous pseudo selector I mentioned, slotted, that I would consider that to be advanced styling when it comes to shadow DOM. But these next two I think are pretty cool, just because it got me thinking about how I could build some components without using like a framework at all, like Angular or React, just ditching those completely for some very lightweight web components. So the first one is host. I used that before earlier without any type of parameters, anything. Host just means that you're targeting the shadow root. So in our case, we have nav is our shadow root. So host is just targeting nav. If you've used Angular, you've probably seen this selector before. In this situation, I've actually added this demo class as a kind of a parameter here. And what that'll do is if the shadow root node has that class demo on it, then it's actually going to change, it's going to apply that host demo styling to it. And then the follow-up to that is host context, which basically does the same thing, but instead of the class being applied to the shadow root, it's the class of the container that the shadow root is in, or the context that the shadow root is in. Kind of the classical example of this, and probably what I would use it for, is theming. So in this case, I have an example of having a host context with dark theme, and then I just switch the colors around. So if that header was placed in an application that had a dark theme enabled, then it would reflect that, and you wouldn't have to be doing any crazy hacking things on that web component. Speaking of crazy hacking things, shadow piercing selectors. So as an Angular developer in like full-time basically at JB Hunt, I see these all the time. I'll explain that in a second, but shadow piercing selectors, you would see them normally as /deep/ or the shadow pseudo selector. The whole purpose of those was to allow consumers of web components or shadow DOM to reach into that, reach across the shadow boundary and modify anything they wanted to. So in the previous cases that we've had with shadow piercing selectors, you would be able to override anything in that header that you wanted to. That breaks the whole concept of shadow DOM, and that's kind of what the spec writers decided as well. So those have been deprecated, and then in Chrome 63, the latest, I believe they're removed completely. There is something kind of in the works called CSS shadow parts. It is a unofficial draft specification, which for front end, it could change 100 different ways, but that's supposed to offer more tools in order to style shadow DOM without completely destroying the concept. I'm not going into that because it is an unofficial draft, but it should help relieve some of that pain if it ever comes to fruition. Okay, so the last thing that I'd like to talk about is emulation of shadow DOM. So when I talked earlier about the fact that Angular has the host pseudo selector, and it has shadow piercing selectors still, even though they've been removed. If you use Angular, and I think some other frameworks do as well, they actually will emulate shadow DOM, or they'll emulate encapsulation. So in this instance, I have an Angular component which has view encapsulation set to emulated. That's the default. So in this situation, basically what Angular does in order to get encapsulation is it will actually take your component that you've made, it will append an attribute to it, a auto-generated attribute, and they'll take that same attribute and add it in your CSS, basically adding more specificity to your CSS in order to create a feeling of encapsulation and shadow DOM. The shadow piercing selectors in Angular, when you're using emulated, all they do is they just remove that specificity from that specific CSS selector. So it's not really actually, piercing the shadow DOM. You can see that down in these bottom images of the compiled Angular code versus like the two things I have underlined are the auto-generated tags. Angular does actually support turning on true shadow DOM now, though. So with that, I have cruised through this a lot quicker than I intended. But I would love if anyone has any questions, we can talk through some of this. So there's a bit of delay, right? So if anyone has any questions, you drop them in the comments. No questions? Does everyone fully understand everything about Shadow DOM now? I would take that as a win if that's...
Lucas, I think you did a really good job then.
All right. Well, I'll just go ahead and say thank you. I know it's a lot of information cram-packed. Oh, okay.
There we go.
A couple of questions. So first, the Vue question. So I haven't used Vue enough to know what they're doing for emulation or what they're doing for component styling. But I believe most frameworks are doing something in order to kind of either do shadow DOM or emulate it. Because otherwise, large-scale projects with components like that, you're just going to run into collisions all the time. So yeah, I'd have to look that up on the Vue part though. And then it's typical scenarios. What are typical scenarios where developers have needed to use shadow piercers? In that situation, what I see normally is for Angular specifically, because Angular is very, very component based. Like, let's say that you're building an application with just vanilla JavaScript and web components. In that situation, you're thinking very clear around the boundaries of your web components. In Angular, because everything is always a component, sometimes components will get built that aren't really, let's see how to phrase this. They are kind of not really great boundaries around their components. And so when something goes to consume that component, they need styles to cascade through those components. I haven't really seen, the best reason I've seen for using shadow piercing selectors is if you're using a component like a small component library, like little bits and chunks like buttons and input boxes and things like that, where you need to modify, you have a UX design where you need some specific input box and it just doesn't support it. Well, then you might have to use shadow piercers in order to do that with Angular. If I don't answer your question, call me out on it. If like I don't answer it well enough, because we don't have this back and forth we normally would have in person. We don't need Shadow DOM when we're using a CSS library like Material UI, correct? It would depend if you're talking about the material, like the raw, because there's Material CSS and then the Material team. There's also various component libraries for different frameworks that Google develops. I would say no if you're only using the CSS that they ship. If you're having to like override things and if you're bringing a lot more custom things to the table, you might have to. But if it's just like back when if I'm doing just a side project where I'm using some out of the box thing like Bootstrap or Material or Tailwind, I'm just using their CSS classes. I'm not doing a bunch of complicated things. Then I'm not going to be like, I don't need Shadow DOM for that. Is it usually a case of rethinking the problem, or are workarounds sometimes necessary? I'm assuming that's in reference to the shadow piercing selectors. So going back to that, I think for the cases I've seen, it's often a case of rethinking the problem and rethinking how you're actually kind of drawing the boundaries around your components. If you're having to constantly reach into a component that you've built yourself in order to modify some piece of it, it probably needs to be rethought. But like I said before, if you're consuming something, if you're consuming a component library that has encapsulation, then sometimes it is necessary. And then finally, we only need it in the case when we use CSS directly. I'm not sure I follow on that. You may need to restate that for me. We only need to use it in the case when we use CSS directly. Yeah, let me think on that. Yeah. Is JavaScript encapsulated as well? So this one, there was an option on that I showed before. Oh, wrong button. When we actually create the shadow, so I guess yes and no. Events actually do flow up. So there is a list of events that will bubble up through Shadow DOM. And then when you're actually creating the Shadow DOM or the shadow tree, there's this mode here, mode open, basically means that you can, it's accessible via JavaScript. It's recommended that you keep it open. I would probably look at some of Google has a really good kind of statement on like why you do or don't in those situations. So not really. I mean, in my situation, it wasn't encapsulated because it is all in the same project. But if you're building a web component, then the JavaScript for the web component, I mean, your events are bubbling up, but your JavaScript, it's contained, I guess, if that makes any sense. And Northwest Arkansas, NWA, Northwest Arkansas, is that the, yeah, it stands for Northwest Arkansas, if that's the question. And I'm not from Northwest Arkansas, but I live here now. Okay. Is there anyone that I need to go back and we want to talk about any of the other questions? Is there anything that I left out that somebody's like, man, he like completely skipped over X, Y, or Z? Going once, going twice. Oh, okay.
Great overview.
We'll leave it there. So I was, yeah. Thank you so much. Thank you for the questions and the attention. If you want to reach out or ask a question or bug me because I missed something, that's my email, lucas.dorrough@jvm.com. Or I just love to chat about JavaScript or anything else. You can also find me on the Slack group as well, the NWA Developers Slack group. So thank you.
Thank you, Lucas, very much. We appreciate you taking the time to join us this evening. All right. Are you guys ready for some fun with JavaScript Jeopardy? Welcome, Blake. Blake, as we mentioned before, is from Fayetteville JS. He is going to run the show for Jeopardy. So, Blake, are you ready?
I am ready.
How are you feeling about it? Let's okay, remember. Say that again.
I said it's a little weirder doing it this way because you can't see reactions. So no one's going to know if any of these jokes are funny or not.
Yeah, feel free to type in the oohs and ahs, you guys, so we can have some expression. Well, let's get started.
Okay. First question. Please remember for Jeopardy, I'll give you the answer and ask me the question. So the first person that types in the question, I'll call out your name. Okay, so the first question is the type of function definition that uses let, const, or var.
First class, is that the answer?
That is not the answer.
That is not the answer. Any other takers? What is? Fair, I didn't even...
Thank you, but no. Ricky, not quite. Keep guessing, y'all. You're getting warmer.
We have what is statement, declaration, 42. Keep them coming. Anonymous?
Nope.
Nope. Okay. What is a function expression?
Oh, Ricky's got the answer.
All right. Way to go, Ricky.
I know that guy.
Okay, question number 2. What is the best way to cook a gator? This one is not tech related. It's just one of those fun ones. And doesn't have to be answered in the form of a question. Since the question is a question. Alive. I don't think that's one. Wrapping bacon. Also good. Grill for 4 hours and remotely. I mean, I vote for remotely personally. All right, Blake, tell us, what is the answer?
In a crock pot, of course.
Of course. Okay. Next question.
So this is the way to enable use of JavaScript modules starting in Node 13.8. There are actually 2 answers to this question, and either one will be fine. I don't think they liked the joke.
It was a good one.
Clear 13. Nope. Not what is it?
Import?
No.
Sudo enable JS modules. JK.
Everyone just tried to type that.
All right, Blake, what's the answer on that one?
The answer is either what is a MJS file or what is type equals module in the package JSON.
Nice. Okay, next question.
All right. This is all you.
What do you call a bee that can't make up its mind? No, 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 no. Undecisive. That is really close, but not quite. A wasp.
Oh, somebody got it. Somebody got it. What is a maybe?
Oh, what is a maybe? Correct.
Nice.
Nice job. Well done. A maybe.
All right. So next question. Those are some serious dad jokes too. Yeah, only Ricky can tell better dad jokes than that, I think. So this is the JavaScript standard library method that will insert an element into a specific position in an array. Everyone is Googling.
Oh, yeah, I didn't think about that.
Yeah.
One of the advantages.
Yeah,
What is Splice?
that is it.
There we go.
Y'all are killing it.
I
You did a
know.
good
3
job.
people got that one. That was a good one.
Yeah.
Okay.
So I think the next couple questions, if I remember correctly, are sort of framework related. So this is the React hook that fires synchronously after all DOM mutations have happened.
What is Angular?
Incorrect.
Use effect.
Nope, close.
It was close.
Jeez,
What is use Angular?
also not correct.
What is Ember?
You guys are killing me.
What is use callback?
No. All right, so the answer to this one is, what is use layout effect?
Oh, Ricky just got
Ricky
it.
just got it. Yeah.
Ricky is
I
on fire tonight.
Yeah, I kind of thought Ricky might get that one. So, okay, the next question. What is the code name for the most recent release of Ember? You better know this one, Kelsey.
Diesel?
Close. Man, that's so close. Octane, Kelsey's got it.
Octane. Very nice.
This is another. Next one's you.
What do you call monkeys who shared an Amazon account?
Oh my God.
Anybody.
It's really hard with the delay.
Yeah, I know. I thought it might be an issue. Oh, close. Amazon Primate.
Oh.
I mean, that's basically right.
Yeah. Let's go ahead and give it to him.
Okay.
Yeah, they're primates.
They are primates.
All right, next question is, what's the name of the new compiler in the most recent release of Angular? All of you Angular fans that I've seen out there should know this one. Yep, Ivy.
Ivy. Nice job. Why shouldn't you use beef stew as a computer password? I hope we get some ha-ha-ha's out of this one.
This is my favorite one by far.
Because it's the 4th one. Not quite. Because it lacks bit entropy.
No.
Okay, shall we?
All right, yeah, let's do it. It's not stroganoff.
Stroganoff.
Yeah.
That was cheesy.
Yeah, it's good. I like it. Okay, so this one is, this is the name of Vue's equivalent of React hooks.
Life cycle hooks?
No. I think this just came out, I don't know, like 6 weeks ago or something, maybe a little bit longer than that.
So it's still relatively fresh in everybody's minds.
Yeah, yeah. If we have some Vue people, what are claws?
What are claws?
No. That's a dad joke too.
No idea, but it really should be Vooks.
Yeah.
All right.
Okay.
Let's give the answer.
This one is, what is the composition API? Which is a super fancy name, right?
Very fancy. Agreed.
Yeah. Get ready.
How can Santa deliver presents during a thunderstorm? Yeah, Lucas, that was a missed opportunity with the name. Agreed. Santa delivers presents how? Oh, somebody's got to get this one.
Yeah, come on, guys. Yeah, I know you guys.
Ricky should know this one.
Yeah. This is old-timey dad joke, Ricky. Come on.
Reindeer.
That is right.
This is true.
That's right. It's Slave
Very true.
by Reindeer.
Well done.
So the next one is, this is the name of the JavaScript convention that allows use of function declarations before they are defined. Yep, hoisting.
Hoisting.
Both of you got it right at the same time.
Yeah. What do you call a thieving alligator?
Why are there so many alligators? Oh,
I don't know. I accidentally hit the button, but maybe nobody else saw it. It was so fast. I mean, we'll see when this delay comes through if anybody caught it. Saw it. Florida man. What was it, Matt?
A crocodile.
A crocodile. Nice. There we go. Yes. Sorry, guys.
Better.
I ruined that one. Sorry.
Okay. The JavaScript standard library method that allows you to concatenate all subarray elements of an array. This one is a newer addition to the standard library. Ricky, you're close, man.
What is flatten?
Yeah, it's really close. It's too long.
Ray, Florida man. What is Flatmap?
So it looks like Rita got it. It's array.flat.
Oh, they must have all came through at the same time. Good
Yeah,
job.
after the delay, we'll have like 5 that just
come
pop
through,
in. Yeah.
What do you call a pig that does karate?
Come on, I know you guys can get this one. Yep, done. You guys got it. Yep, nice job. Dave, you got one. I'm so proud. Okay, this is the type of conditional statement that can be used to try to trap errors. Also common in many other languages. Yep.
Nice. Try and catch.
Yep. Try catch. I think there's the last one. Last one. For $1 million.
How much money does a pirate pay for corn?
This one's hard. I don't. Yeah.
It kind of is.
Yeah.
Don't they just pillage and steal? Technically, you're right. Yes. An arm and a leg. That was a good one, Kelsey. All right.
All right.
Shall we?
Yep. They pay buccaneer.
A buccaneer. All
I
right.
don't like that one. I don't like that.
I didn't like that one.
The stroganoff one was so much better.
It was. All right. Well, good job, Blake. Thank you for joining us to host JavaScript Jeopardy.
Good job, everybody.
All right. Everybody, thank you for playing. Sorry for the delay. And I'm going to bring in Chris, our next speaker. Chris, welcome to the show.
Hello, hello.
All right.
Ready for me to get started? Okay. My name is Chris Whited. I'm giving a talk today over serverless GraphQL. The goal of this is to kind of have a conversation about how backend services are migrating from a more monolithic architecture to a microservice-oriented architecture and the problems that has created, and how a GraphQL middleware solution can aid in helping with that. So that's kind of the gist of what I'm going to be talking about today. A little bit about me. I am a senior software engineer at this.labs, where we are the sponsors of this event, where Tara and I work. I am an open source contributor to Nest.js, Apollo, a few others. I am a blog author for Ultimate Courses, as well as this. I am a speaker on GraphQL, Angular, Golang, Node.js. I am a mentor for the Angular girls in NG Girls KC. I am a host of the Modern Web podcast, and I've done a couple of episodes of those as well, and of this event and this meetup group in Kansas City and Arkansas. And I'm a technical lead on the This.Labs apprenticeship program, where we do a lot to help women coming out of boot camps and help them to bridge the gap between post-boot camp graduation and becoming an engineer and helping them get a job. Check that out, opensourceforall.com, and some others. So to start with, like I said, I'm going to kind of go through like a sample scenario where we're going to start like down the path of a company that has hit this point where they have these monolithic architecture and they're trying to split it up because they read something online about microservices and now they're wanting to do it. And yet I've yet to see anybody who does these kind of things. Everybody has an idea. And so this title is, what the hell is a microservice? All in all, loosely coupled architecture design pattern of independently deployable and testable services that are supposed to be organized around business capabilities and owned and maintained by a small team of engineers. The idea here is that we have these, like, we're going from these large scale applications that contain lots of business logic, lots of areas of business logic, and we're going to split them up into independently deployable chunks of code or services that allow that focus on one area or one problem, kind of a single responsibility solution. And then you communicate between these services over HTTP or messaging or streams. And they allow us to break up the large monolithic services into smaller services that are maintained and deployed independently. The idea is, if I'm going to introduce a new feature into like a payment service, and I already have an authentication and a user service in this monolithic architecture, I shouldn't have to like deploy the entire application to make a small change to a payment service that I'm adding in, right? Like, why does everything have to go down to add a small piece of unrelated functionality? So microservices, the goal is to split that up, create those like shell small services that allow like business functionality to exist in a small one that's independently maintainable and deployable. But because this is software, there's no silver bullets. Everything comes with trade-offs. So the trade-off, the downside to the microservice approach is it puts strain in other areas of your organization, strain in areas like DevOps. So now instead of having to deploy and maintain one service, you're having to deploy and maintain 4 services or n number of services, right? And so your infrastructure goes up, your DevOps work goes up. You have to communicate and maintain data between 4 different services or n number of services, in this case 4. The idea is that, like, yes, is it easier if you're working on one specific service? Yes. If you're just working on, in this case, an auth service, it makes that a lot simpler, a lot smaller, et cetera. But your area, like if you're looking at it from a global perspective, or if you're looking at the entire system, there's a lot more to maintain, a lot more to work on, a lot more to be considered of. And if you're considering this from a front-end perspective, or a UI, like a UI doesn't care that users and authentication and transaction and payments are 4 different services. That's not their goal, right? Their goal is like, I need to authenticate my user. I need to be able to get their user profile data. I want to look at their transactions. I want to look at their payments. And now I'm having to make requests to 4 different APIs that follow 4 different sets of potentially business logic that may follow 4 different steps and naming conventions because they're separate teams and they don't communicate well, et cetera. So with this setup, the next part of this conversation is GraphQL and what it does to help this problem, and then an idea of creating a GraphQL middleware layer to help us like bridge that gap between a microservice architecture and how we can consume that and visualize it from a UI or from a front-end perspective. So a little bit of an intro into GraphQL. GraphQL is a query language for your API. It allows your clients to specify what data that they need from your API. And it uses a typing system that allows you to define and describe your data and its structure. So it uses a strong typing system that allows you to come in and say, I know that this is what I want my structure to look like. I know that these are the fields that I have. I know that these fields are required. I know the name of them. I know how I can query data. I know I can say, I want this data, and I know it's going to return an array versus a single instance. I know that these fields are required in my query. Maybe I want to mutate data. I want to, where I know then, like, this is absolutely required. I have to send it an object that looks like this, that has this shape, that has these fields that are required, that has these fields that are not, et cetera. It allows us to specify enums and interfaces, all these kind of cool things. So it came about by Facebook around 2012 when they were redefining their mobile applications. They were switching from at the time, the Facebook mobile applications brought in entire like pre-rendered HTML pages into your app, or into the phone, into your app, and it would crash constantly, just constantly. And so they were trying to figure out what is a way to solve this problem. And then they realized we have this vast data set of data that they steal from you. I mean, that you give them, and you can look at it, and they wanted to be able to show you as much of that data as possible without crashing your UI, and with giving a positive user experience. So they came up with this idea of like, what if the UI, what if the client, what if the consumer was able to tell me what data I want, and how would that give us an advantage? And so versus a traditional REST, this helps to solve a few problems such as overfetching, where I'm getting more data than I care about. For instance, if I want to, look at a list of users. I don't need all of the sub or nested or certain pieces of data from that user. I may just want the ID, their username, and email, their name, and a role, right? But if our user data or if our user object is very large in a traditional REST pattern, we'd get that entire user no matter which side we're requesting. If we want a list of users, you still get this object. If we want a single user, we get that same user object. With GraphQL, we can tell, like, all right, hey, I'm looking at a list here, and I really only care about these 4 fields because I'm just viewing this in a table structure. It's pretty lightweight. I'm looking more for speed and mass data consumption than I am for a detailed data consumption. So GraphQL helps to solve that by saying, like, these are the fields from this object that I would like. The other side of that is underfetching, where we don't get enough data. The most expensive part of any interaction with your API is the HTTP layer, where your client is having to make a handshake. It's having to say, this is who I am. These are the rights that I have. Can I see your data, please? And then your API goes yes or no, right? Well, that's expensive. And that is the most expensive part of that transaction. And so when we don't get enough data, that means we have to spin up and get another, we have to make another call. So we have to go through that same thing over again, right? And so now we're saying, like, I want a user. Okay, here's your user. I also want their payments. Okay, here are their payments. Well, I actually also want this too. So now we're making multiple calls and we're going through that expense multiple times when maybe that isn't necessary. And so GraphQL helps to say that by saying, like, here's the entirety of the data set that I want to get. And then you as the consumer of that data need to come in and say, like, I understand that this is going to potentially take longer because I'm looking to get more data. Another issue is all or nothing. So in REST, if I make a request to an endpoint, that endpoint fails because field number 2 is required and we didn't get it, then we don't get anything back. We get a 404 response or an error response. GraphQL has an approach where we can, when we make a request, if there's an error or an error occurs during that request, it will give us the data that it can, as well as an error statement or an error object telling us here are the fields that failed to be retrieved. So it gives us both, right? So we can say, I successfully retrieved these fields, and there was an error, it failed to retrieve these fields. And we also have request batching. So with GraphQL, we can send it a multitude of queries, and we can say, hey, I want to run all of these. I want you to run all of these queries and give me the entire data response back. So this is really, really helpful for such a thing like a dashboard, right? So if you're going into the application first time and you want to view a large set of data, this is really helpful because we can batch that query and say, all right, I want you to run all of this, give me all this data. And I know that initial load time might be slower, but my trade-off here is that I get that data back all at once, and I can provide like a loading indicator to provide a good UX. This is a pretty positive user experience. One of the things with batching is that the response will be based off of whichever query takes the longest will be what determines your response time. So the power of GraphQL to me is in the resolvers. A resolver tells it how to resolve a piece of data, whether that's an individual field or whether that's an array or another object, et cetera. And I'll show you that a bit later. But the cool part of this is the resolver is agnostic. It doesn't care, right? It doesn't care if that is getting us data from our, if it's getting us data from like a promise that we're going to go to another API and retrieve that data, whether it's a call to a data set, like a database of some sort, whether it's like a service layer call, whether we call it to AWS S3 to retrieve objects out of a bucket, et cetera. It doesn't care, right? As long as it resolves to the data object that we expect, it doesn't matter what that resolver is. So that makes it very, very powerful and very dynamic. And the GraphQL uses the schema definition language, SDL, to define your schema, your types, your queries, your mutations. This is what creates that strong typing system. This is what our clients consume that allow us to view and look at our data, know what it looks like, know what our types are, et cetera. So kind of migrating with our example, how do we use GraphQL to help solve this issue of we want to migrate to a more microservice-oriented architecture, but we also want to maintain like ease of use and ease of consumability from our clients. So GraphQL is hinting this solution, and there is a framework out called Apollo. They offer a suite of JavaScript libraries that you can consume both on the API side, so creating your API servers to expose a GraphQL endpoint, one of which we'll go over tonight, and things like Express or Koa, Nest.js. Then on the client side, they also create libraries where you can consume that data. So React has them. I think it's I used it the other day. It's Apollo React hooks. So it uses a hook framework so you can run your queries, run your mutations, and consume that data. It also has a cache library built in. So it kind of eliminates the need for a Redux solution. So NGRX in the Angular world, or Redux on the React side, Vuex on the Vue side, as it handles caching for you. It already stores that stuff locally, and then you can tell the library, when I run a query, when I run a mutation, do I want that to pull from my cache, or do I want that to go to the network directly? So with this framework, we can utilize this to get the best out of both worlds. We can build a GraphQL API using the Apollo Lambda server library, which allows us to create and expose a GraphQL API through the AWS Lambda serverless framework. So we have a serverless function, and it takes an API gateway event as an HTTP event, and then it returns a GraphQL layer, which is really handy, right? Because the serverless framework allows us to expose multiple functions where we can specify multiple endpoints. And but with that, like in your serverless file, if you specify multiple functions, you get multiple functions deployed, which is good, but that's more to maintain, right? With GraphQL here, we expose one function that exposes a GraphQL API that has all of our queries, all of our mutations, all bundled together. So you get, a very, very tight consumable library that exposes one function, but still have the same functionality. So with this GraphQL API approach and serverless, it makes it very, very fast, very light, very easy to maintain, and it allows us to create what we're calling, at this dot, we utilize this practice a lot, of a data aggregation middleware. So that way we can have these disparate data sets from microservices and databases that are spread out, that are separated, intentionally due to business constraints or things out of control of the UI, but still exposes all the data. So an example of this architecture would look something like this, right? So instead of a client or a website, a mobile app consuming from an API directly, we introduced this GraphQL API middleware layer. The requests go to it. It exposes their API. It has your types, your type definitions. It exposes your data contracts, the queries that are available, the mutations that are available. And under the hood, you as the UI don't have to care about this, but under the hood, it then connects to these multiple API microservices or maybe data sets or S3 buckets, and the UI doesn't have to care, right? And this does a lot for us. So the advantages of this is it separates the concerns of the API layer and team from the UI layer and team. So I mentioned Conway's Law here. The gist of Conway's Law is that software is constrained to communicate only as well as the organization who writes it. So if you as an organization communicate well, your software will too. And the reverse, which is often more true, is that if you as an organization do not communicate well, neither will your software. And so a lot of times we see these like hostilities or anger or lack of communication between your API team, your backend team, and your UI team and your UI layer. And so this separates out those concerns where the API team no longer has to care about whatever you're concerned with in the UI, whether it's these data contracts or et cetera, and they can focus on like, we want to make these small microservices that have single responsibility, or somebody decides we're going to write everything in Rust, or somebody decides we're going to make everything serverless functions. It doesn't matter anymore, right? Because the middleware layer that we're building in GraphQL allows us to like abstract all that away. So the UI says, this is my API, it exposes a GraphQL endpoint, and these are my data contracts that I know, which is my second bullet point, right? It requires these teams to come together. They have to work together to come up with an agreed upon data contract. And it allows you to say like, all right, when we know that when we look at a user, this is what we request from a user. Sorry about the dogs. We know that this is what we look at from a user, and these are all the fields. These are all the types of those fields. Same with all these other objects, right? It allows the teams to come together and agree on that contract. And like I said, the UI layer then gets to consume that data from a singular source. It doesn't matter if you have 30 microservices or 2 or a monolith or 10 microservices and a bunch of Lambda functions. It doesn't matter, right? It's the microservice, the backend is like the UI is agnostic to that. It no longer cares. And you can push everything like off and logging into that central middleware layer. And all your requests go through that single point, and then they know where to go to get the data. And it allows you to visualize and see the data model for your entire system. You can see it all. You can see how you're going to consume it, where different things are, or how they connect, et cetera. And the UI can consume the data that they need and name it what they want with aliasing, and it allows them to consume the data in a much more a handy way, a performant way, or not, right? You could query the data as you see fit. So a lot of people like to look at code. So I'm going to show you a very, very simple example of this. So this is a very, very lightweight serverless function that exposes a GraphQL API. It's written in TypeScript, and it uses the Apollo Server Lambda framework. This is my serverless YAML file that defines my functions and some basic setup here. So what I'm telling it, the important part here is I'm exposing one function. I named it GraphQL. The handler is in a handler file, and I'm exposing two HTTP events, a GET event and a POST event. The reason for that is my GET event allows me to use GraphQL Playground, which is like if you ever used Swagger or Postman, it allows you to basically view your GraphQL API and run queries, run mutations, see your docs, see your schema, etc. And then, so take a look at our schema here. It's very, very simple, very light. Just for an example, I have a payment model that has an ID, a transaction ID that would be a foreign key between them, and a transaction that has an ID. It has a user ID, which links it back to a user, and then a user, and then some queries. So this is the SDL. This is our schema definition language here. This is what the GraphQL understands as what represents our schema. And we use two object types. We have a type, and we have there's multiple, but the two big ones are type and input. A type represents data that we're going to retrieve, right? So in this case, I'm defining a type payment that has an ID, and here this is me typing it. This is where our strong typing comes from. So int would be, as you can imagine, an integer. The exclamation means it is required, as in it doesn't mean I have to request that piece of data. It means if I request it, it has to give me a value. So if my value for amount is null, when I request it, it will throw an error, and it will put that in the error block that you requested amount was null, amount has been declared as not null, right? So this is really handy. Now we can look at our API and go, I know that if I'm looking for a payment method, I will get a payment method. I know that I will get an amount, and I know that it will be this data type. And then that makes consuming this much stronger. We can create much more resilient components. And my friend Matt, who happens to be in this call right now, would say rock hard components. But we can split those out, and because we know what our data type is, we know what we're expecting to get back, and it's guaranteed by our type, and we guarantee it by agreeing on that data contract. The next step of this is the resolvers. And this, again, is where the power comes from, as I mentioned earlier. So this allows us to define, how do I resolve my query here, right? So I have this type query. This is what is like the top level. It exposes, here is the available queries that I can run on my system. So I define a few. I want to get a user. I want to get a transaction. I want to get a payment. And again, this is a resolver. Under the hood, what this is doing is actually making an HTTP request to a microservice that I built using Nest.js that says, it makes an HTTP request and says, HTTP localhost 9001/user/ID, right? And this just returns a promise using an HTTP request and gives me my data back. Same with these other two. These are all disparate microservices or separated microservices written in Nest.js. So I have one for transactions, one for payments, and I use the Apollo data source framework because it handles caching out of the box and some other really cool stuff. And then the next side of this that again comes from the power of the resolvers here is what I'm saying here below. So take this section here where I have a transaction. That maps to my transaction type. So as you can tell, query, transaction. And then under transaction, what I'm saying here is that when a user or when the client says, I want a transaction and I want the payments field from the transaction, this resolver comes in and says, okay, you requested a transaction. I know in order to get the payments from a transaction, I need to make this HTTP request, which is going to, again, use just a data source under the hood, makes an HTTP request to a different microservice. And so that's where this like data aggregation thought comes from, right? If these are separated microservices, but my UI needs to consume them, it doesn't know that they're separated, right? It doesn't need to know. And now it doesn't matter. I'm telling it, hey, I want to get a user. I know that a user has a list of transactions. And to get those list of transactions, I need to make an HTTP request to this separate service to get those transactions. Or payments in this case. And here, if I'm looking at a user and I want to get that user's transactions, I will do the same. So it allows us, that's where like I said, that's where the power comes from. It allows us to say, well, however I can consume, however I need to get that data, whatever I need to do, this is how, as long as it returns this data type, I don't care. And my UI doesn't care. It says, I want this query, I want this chunk of data, and I want it to, these are the fields that I care about. I don't care how you have to go and get them. This is what I want. Please go and get them. And then we tell it in the resolvers and the schema, this is how you go and get me. This is how I resolve. So again, very, very simple. I'll run this very quickly here. As I mentioned, here's our GraphQL playground. This allows us to consume our GraphQL API. Or it's just a handy UI where we can run queries and mutations, et cetera, against our schema. We can also view our schema. So we can click here on the right under docs and schema and view our schema and understand our data types. So we can say, get a user. What does a user look like? Well, it has these fields. And here's the arguments that are required. And they are of type int. And then you have to give them to me or not required. This is what a transaction looks like. Awesome. And if you request a payment, this is what a payment looks like. The square bracket surrounding it means it's an array. So now if I were to request this, I get a user, I get those users' transactions, and I get the payments associated with that transaction. But because this is GraphQL, if I don't care about all of that, and I just swap those fields, I can get that too. And now, under the hood, those HTTP requests weren't made. It didn't go to my transaction service and retrieve my transactions from my user. Same with it didn't go to my payment service and receive all the payments for that transaction. I'm going to stop. I think that's it. Let's see. What else do I got? Oh, presenting again. Okay, so my lasting impression here is GraphQL and serverless allows us to create lightweight, fast middleware layers to consume disparate data. And thank you guys so much. If you're looking for help in the modern web, here's a shameless plug. We are this dot. If you want to check out labs.this.co or email hi@this.co, we are consultants. You can have me on your team teaching you and ranting and raving about GraphQL all day long. I'm going to go back to here and stop sharing my screen. And now questions, anybody? Also, if you said a question earlier, I didn't see it because the screen was up and I was sharing that. Sorry. So I'm going to go through the questions that I might see now. Let's see. How do I don't know how to show this onto the screen. The question is GraphQL Playground different from Graphical? Technically, oh, nice. Technically, yes, they are different, but they do the same thing, right? GraphQL Playground and Graphical do the same thing, where they basically just say, here's my UI, or here's my GraphQL API, and I want to be able to view it. So yeah, under the hood, are they technically different? Yes, but they do the same thing, one way or the other. GraphQL Playground, I think, looks a little bit better from a UI perspective, and it happens to come with the Apollo Server Lambda, like it's baked into it, so I usually use it. Oh, there you go. GraphQL Playground is made by Prisma. So are there any other questions? I know that there's a bit of a delay, so if you do ask, I will answer once I see it. Okay. I'm going to pass it back off to Tara then. Feel free to follow me on the Twitters at CMWhitehead. You can hit me up on there and ask me whatever questions you want, I guess. But anyway, yeah, thank you all for listening.
Chris, thank you so much for presenting to us tonight. That pretty well wraps up our evening. Does anybody have any general questions? It looks like we might have a couple. How excited is your dog to be on YouTube, Chris? And looks like we actually have one more question, so I'm going to bring you back in.
First off, the dog is very excited. In terms of deployment for the middleware layer, yeah, it's a serverless deployment. So it's a serverless function, so it would be deployed as a Lambda serverless function. So it would not go to ECS, right? It follows the same rules of serverless. In this case, you could have like an actual server, an Express server, or Koa, or whatever.
Okay. Thank you. Appreciate you. Okay, well, to wrap it up, I just wanted to share our announcements one more time. Again, tomorrow we have a few events. We have our partnered online event with GraphQL Madrid at 10 a.m., our monthly React Online at 2:30. That's something that happens every month. Every Thursday, we have an online meetup, whether it's React, Angular, or Vue. So please join us for any and all of those. And then we have another modern web meetup tomorrow night that normally would have been hosted in Kansas City, but it is online, just like this one. So please feel free to join us. Next week, we have our first GraphQL fireside chat about platform and data-centric use cases with GraphQL on Tuesday. Plus, we have the State of Vue with Evan Yu on Thursday. Again, you can find all of these links on our website, this.co. And then finally, if you, again, are following us on social, you know about our new JavaScript Marathon series that we have started. We just kicked it off last week, and we continued it again today, and it'll come back next Wednesday. Every Wednesday, we'll be sending live trainings throughout the day covering various topics on React, Angular, Vue, web performance, and RxJS. We have a full schedule of training sessions of what we'll be covering at javascriptmarathon.com. So please go check them out and sign up for your links. Again, every week it's something new. So thank you again, everybody, for being here. This was very enjoyable for our first Modern Web NWA, and we look forward to seeing you in a couple months for the next one. Hopefully by then we'll be able to visit in person and really kind of get to meet and know each other. So please follow us on social. We're on Twitter, Facebook, LinkedIn, all of them. So thanks again, and hope to see you soon. Bye, everybody.